Hello, everyone, and welcome to our Day of Learning session on building effective AI agents with Model Context Protocol, or MCP. My name is Peter Double, and I'm a Principal Product Manager at Red Hat, and I'm joined by my colleague, Cedric Clyburn, Senior Technical Marketing Manager.
Thanks. It's a pleasure to be here with you, Peter. Pleasure to be joining you guys at this AI Day of Learning. It's going to be a fun time.
So here's a quick look at what we're going to do today. We're gonna start with MCP and why it matters and what it is, then cover some of the current challenges. After that, I'll walk through how Red Hat is approaching MCP. Cedric will then take you through a live demo, and we'll wrap up with the roadmap and what's coming next. By the end, you'll understand the value and challenges of MCP, how Red Hat sees enterprise agentic AI. You'll see MCP in action on OpenShift AI, and you'll know what's coming next.
Absolutely. And I think before you learn about MCP or Model Context Protocol in the world of agentic AI, it's really helpful to rewind a little bit and understand the evolution of AI in the past few years, because the models as we know it are changing, right? From GPT-4 to 5 and everything that we're using in our daily lives. But the applications that we're using and that are built around these models are also changing. And so if you think about the first version of ChatGPT and those large language models of the early 2020s, it was really simple, right? You would ask the model a question, say, for example, what is Red Hat? And that would be processed sequentially just by breaking the text up, translating that to tokens, processing that with the LLM and getting a response back. But that response back was only based on the data that it was trained with, right? So OpenAI or Anthropic with Claude pretty much dictated the answers that you were going to get back because you were simply asking this knowledge base that they had trained on from the entire public internet. But for enterprises, right, this isn't very helpful. Think about our internal documentation or our JIRA tickets, right? Or maybe meeting transcripts and so much more. How do we interact with that type of data? So that's exactly where we needed some type of storage and retrieval process that's built around the LLM, because the data sources that we have as humans that are helpful in our everyday work are also helpful for these AI applications to give back better and more helpful answers. And we learned that adding additional information to the context window of the LLM would result in much better responses from the model. And this is the technique that's known as retrieval augmented generation, or RAG, which powers almost all AI applications today. And this uses vector or graph databases where you can perform semantic search. If I were to ask, hey, how do I create a data science project in OpenShift AI? And we've got a RAG pipeline set up, well, that information is going to be searched through a vector store provided in the context of that LLM. The LLM would take that information and provide a succinct answer to the user. And that's all done at real time using dynamic information. So we supplement what the model knows with this additional information. But there's one issue, because there's some cases where constantly providing this information from a database isn't necessary. And when models like GPT-4o came out that had reasoning capabilities, why not just allow that model to ask for the information that it needs when it needs that information? And so this brought us to this world of tool calling and today's version of agentic AI, which has become such a powerful way of accessing and interacting with data sources that we use every day. So in this example here, we have the weather app, but you could think about JIRA for our tickets and for sprints, or GitHub in order to pull information about repositories and so much more. So that when a user asks a question to our AI application, the LLM is aware of various tools that it can use. So previously we had RAG just to search a database, but for example, here we could go to the AccuWeather API and pull today's weather forecast. And so in an engineering context, maybe we'd like the maybe we want the model to upgrade our code base and maybe migrate to Node.js 22 and commit those updates and create a PR. And so the model is going to be aware of the context, so maybe the code base. It's also going to be aware of the tools it can use, maybe accessing GitHub and creating new PRs. And maybe we can monitor our Kubernetes cluster and see that actually deployed. So that's why the agentic AI and the world of agentic development is here right now, because this is the best use case of LLMs. And as a developer, but also someone who sees these applications being built every day, this is where the real value is. And so MCP is behind that. But how is MCP behind that? Because instead of, as a developer or our engineering team, writing a unique code to call every single tool, so the AccuWeather API or GitHub or Kubernetes or OpenShift, right? Instead of our team doing that and someone else having to create their own version of it and something being outdated or maybe just not standardized within our organization, what if we had a standard like TCP for network communication, but instead of that, for this tool calling behavior, right? What if we had one single API to create our awesome agentic application? And that introduces the model context protocol. And so what this does is actually decouples the orchestration part of our AI application into this MCP layer, where you have a client that can understand what calls need to be made, and you have a server which actually goes ahead and does that work. And so this makes it reproducible and standardized, so that if I make the GitHub tool calling MCP, I can provide that to Peter, I can provide that to you, and we all have the same way of communicating from our LLM to where the data actually is. And ladies and gentlemen, that's really what the MCP standard is. It came out from Anthropic late last year in 2024, but it helps us to use LLMs, whether it's from Gemini or from ChatGPT or our own local model, to call tools. So it lets us build agentic applications without creating this all from scratch. And the ecosystem has been growing super fast. There's tens of thousands of MCP servers, from everything from data storage, communication, productivity tools, so much more. And you can use various clients from ChatGPT to Cloud Desktop that have integrations with MCP to, one, add those servers, but also two, to start using that LLM to make tool calls and really save us a lot of time. So I'll hand it over here now to Peter to talk about what the current state is, and especially you see security is a big part of using MCP servers in the enterprise.
So MCP is a brand new protocol, and as such, it is in its infancy at this point. So there are a couple key challenges that are really affecting the market and, not making it that easy to take things to production. A couple of those really are around the security and trust. Those solutions are coming rapidly, and we are going to see a lot of different solutions on how to make that happen as it standardizes down to a single kind of pattern to follow here. Some of those problems are making sure that we have the correct authorization for tooling, the correct authorization for even accessing the MCP to begin with. There's going to be different technologies that are going to need to help with this and make sure that we can handle all of these different problems that different enterprises are seeing as this protocol solidifies. Now, governance and scaling are something that Red Hat can very much help with. Those are two areas that we really want to make sure we have a solid experience around and that we'll be building towards. And we're going to talk about a little bit exactly how that comes to be. But what we're really going to make sure that we need to have as part of this is really strong identity, making sure that RBAC and OAuth are fully handled within this stack, and so our clients can trust exactly what we're putting out in front of them. This is something that's going to evolve over time as the protocol continues to evolve itself. Also, the life cycling of these MCPs is going to be very, very important going forward. So making sure we have proper versioning and metadata, that we can properly observe exactly what's going on with these MCP servers, is going to be incredibly necessary as we move forward. There's some new things as well for the numbers of tools that you're all going to be having to access. And with that, we're going to need to really make sure that we can make this a seamless, easy experience, both for platform engineers and AI engineers. This isn't just a one-sided argument. So before we actually get into this longer-term vision that I was talking about, let's take a look at how we're surfacing MCP in OpenShift AI 3.0 to get people moving. We're giving AI engineers the ability to connect models to real-world tools right out of the box. Imagine being able to spin up a new MCP server without guessing how it should be built. You'll have a clear creation guide that walks you through the process. Once it's up, you don't have to commit blindly. you can actually try out these MCP servers, trying out before you buy, in the playground alongside your models. So you can see how they behave before bringing them into production. All of this is surfaced in an AI assets listing. Think of it as a catalog for the allowed MCPs that you are allowed to access as an AI engineer. So it's easy to discover what's already available. And because it's integrated with LlamaStack, calling those tools from your models is seamless. No custom plumbing required. The real value is that it enables instant experimentation today. It brings your models and tools together for real workflows. And it lays the foundation for the next stage of OpenShift AI, where these assets won't just be experimental, they'll be governed, certified, and enterprise ready. So for the roadmap, for what we're trying to build into the system to make sure that we have a full end-to-end MCP lifecycle, it starts with the registry and catalog. Think of the registry as a secure staging zone. It's where MCP servers go first so they can be scanned, quarantined if needed, and certified before they're trusted. Once they pass those checks, they can move into the catalog, which is a curated list of MCP servers that are enterprise ready. Then there's lifecycle management. We don't want organizations left wondering what version of a server they're running or whether it's secure. So we're automating the scanning, signing, and promotion of MCP servers while tracking metadata, certification status, and version history along the way. Finally, the MCP gateway is what ties it together at runtime. This is where governance, security, and observability are enforced. The gateway ensures that when agents use MCP servers, policy and RBAC rules are applied consistently. This gives enterprises confidence that they're in control. Altogether, these pieces are surfacing in OpenShift AI, coming up in 3.next. But as I've already mentioned, 3.0 is going to be making sure that you can get started with experimentation immediately. Now we're going to move into the demo aspects of our presentation, where we actually have Cedric walking us through those different demos.
Thank you so much, Peter. Yeah, man. So I'm excited to kind of show off some of the capabilities that MCP allows. And I kind of like to break this up in two different ways, because in the ecosystem right now, you see half people working and building out applications from their IDEs using MCP servers. So you could think of Cursor, VS Code, or Windsurf, where you have the client capability of MCP, and that enabling you to connect to GitHub or your Kubernetes environment, your code base, GitLab, whatever it might be. And then we're also going to take a look at, instead of doing things manually and using a chat client to work with MCP, how we can integrate this into our application using the API LlamaStack in order to manage which tools that we have. So this first example is really fun. And I'll go ahead and probably start sharing here just in a second, so I can show you some of this all live. We did a little rain dance for the demo gods earlier, and so let's see it in action. I'll go ahead and share my screen here. Give me 2 seconds. And good to go. Awesome. Cool. So on the right-hand side, I want to show you kind of this community page of Model Context Protocol servers. Now, I told you this came from Anthropic earlier in 2025 and 2024 that has this protocol for calling tools, but it's more than that. And if you want to learn about it, check out the upstream, which has a lot of different community-based servers. So integrations for your data sources, but also calling tools and APIs and working with different endpoints. And so a lot of that's already been built out. Now, what I want to show you specifically here is 2 MCP servers that we commonly use as engineers, as DevOps engineers, to work with Kubernetes, which is the OpenShift and Kubernetes MCP server, which we contribute to. And we're also going to be taking a look at a community server, which is the Slack MCP server, and combining these together in order to work with our infrastructure to detect anomalies and to provide that into our Slack workspace here. Now, there's a lot of different clients that you can use. I'm using something that's called Goose, which is an open source project that allows me to run these different MCP servers, which at the end of the day, it's an npx-y to the specific MCP server we want to call, and then maybe providing environment variables to actually make those calls to an API. So we'll also see this in OpenShift. We've containerized this as well. So you'll see a cool example after this. But let's go ahead and chat with our Kubernetes environment. Pretty cool, right? So let's say, hey, what's, and I know this is a bit small, happening in our Blackjack AI demo project. So remember, when we have a client, we have the ability to tell the LLM that there's the ability to use tools. So here it just selected a specific pod. So the pod is this Blackjack demo itself. Are there any errors happening? So it's using my kube config, and maybe I have too many errors happening. So let's try this again. In my llama stack pod, get me the logs. And so now it knows, well, cannot find a pod named llama stack. I knew this live demo thing was going to happen. Okay, so what would happen here is maybe it's the kube config. So let me just add that again. I get everything working, and then we actually do it. It can be a little tricky.
It's good luck. It's always good luck to have a breakage in your demos. If they go smoothly, they won't work in production.
Exactly. That's how you know it's real. All right, so let's try it again. We've got those two MCP servers. Let's see, reading a resource URL. Let me show you what happened just a little bit ago. So I'll come over here, and I asked, hey, what's in my Blackjack demo namespace? And we could see we did a tool call to the pods list. So this is one of the capabilities that we have when we run an MCP server, and we can maybe turn some of these off, turn some of these on, do write access or read access for these specifically. And then I could say, hey, post a summary to Slack with the details and typical fixes. And so I'll run that here again. If I can zoom out here a little bit. So I'll hit resume, and then we'll run that here. And then you see that it's, hey, seeing if I have the access to tool call. And then this happened earlier was that, hey, I created a bot with the access key for Slack, and it can tell us, hey, here's what's happening in our cluster. So that's a quick example of the first demo. And we also have another demo I want to show you really quickly, which is building this out into an application. So here in my OpenShift cluster, which we were taking a look at with that MCP server, we have a few applications deployed. So one of these is a Blackjack simulator. And if I ask the AI, it's going to tell me if I should hit or if I should stand. So let's try to ask this model. It says stand. I should probably stand, and let's see what happens. We both got 20. But in the background, we're using a provider to do inference and tool calling. So what actually happened there is we did an inference call. So you can see right here, we did a chat completion to a model that we have running on our OpenShift AI cluster. So we have it here. And then we also did a tool call. So the tool call is also using an MCP server that we've containerized. And this is using something called Notify, and it's just an open source way to make updates to your phone or to a device you might have. And you see right there, we've got a push. And so this is pretty cool to use something like what's called Llama Stack to use kind of one singular API for inference, evaluations, and specifically here, we're using it for MCP servers because that MCP server is running beside it on the cluster using the same RBAC and the same authentication. So that's two quick examples. And if you'd like to try out the game, please, I encourage you to scan this here. We'll create the QR code. And if you want to try out the game, see if it works, and check out that Notify topic, feel free to do so, and hey, enjoy. So Peter, thanks so much for letting me do that live demo. Back to you.
All right, sharing my screen. So we've shown a little bit about how MCP, can come into your application and create quick functionality out to many other APIs that are available. Being able to use MCPs across different enterprise solutions is absolutely a superpower that is adding new magic to all of our different applications. With that, we need to make sure that we have a strong end-to-end experience for MCP, of course, to make sure that we can make sure that these MCPs are up and running, that we can see exactly what they're doing, making sure there's logging and auditability around there, as well as heavy security. So let's just talk about what the next year is going to look like here at Red Hat and how we're going to serve our clients with MCP. In the near-term roadmap, we are surfacing MCP. We are just bringing the capabilities into OpenShift AI, which was no easy task. There's a lot of work around making that work out in the cluster to be able to be accessed easily and to be able to get these things up and running. Once that has been completely surfaced and made easily available for our clients, we will be moving on into other areas, of course. But with 3.0, we are also going to be starting up the partner or ISV MCP server inclusion, which what this means is that we have many different partners that will be listing their MCP servers that have been checked and validated, but not quite yet certified yet. And I just want to make sure people are aware of that because we don't know what certification truly looks like yet because the protocol, as I said before, is in its infancy. So with that, we will have a short list of recommended MCP servers for you to try from our closest partners. Now, once we get past 3.0 and we've made sure that everything is working up to our clients' needs, we are already working on building out this full ecosystem of how MCP will function from ingestion all the way to consumption, all the way past that to versioning and lifecycling of those MCP servers. Now, with that, we're going to be working on bringing all of our clients access to an MCP registry, a catalog, and gateway. These three items together will create a safe, secure, easy to govern environment for our clients. Now, by doing this, we make sure that the platform engineers have a way for them to be able to easily govern these things and feel comfortable about what they're putting out there. AI engineers, on the other hand, which we are serving here, is making sure that they have access to a list of available MCP servers for them to consume. Now, within OpenShift AI itself, we have the experimentation area, but the goal is always to go back to a pro code situation and be able to take that code that you are able to see from the playground and move it directly into an IDE for you to be able to develop against. Now, having all of this capability will give a much better experience for AI engineers to be able to rapidly create these new applications in a repeatable way. Now, we need to make sure as we go forward that we have richer metadata to make sure that we understand when we do decide exactly what certification looks like, that can be followed, but that we can properly scan these MCP servers and that they fit a certain maturity level before we feel comfortable of putting them out there for everybody to be able to leverage on our systems. Now, for the future vision, a little bit longer than that, because it does take time to put these things together. We're looking at such amazing things as MCP as a service. Some of you may recognize model as a service, a centralized, manageable way of accessing models across a company. This helps with cost management, of course, and for making the use of your GPUs. But MCP as a service is a nice fast follow for that to make sure that the company can put out specific MCP servers that they feel comfortable running and manage those, as well as being able to observe exactly how they're being used, what tool calls are being used, and that way they can actually audit go back and audit the actual work that's being done on these MCP servers. Now, we're also taking the AI Hub, which is coming with OpenShift AI version 3.0, and we're going to be pushing in agents, models with the MCP servers as well as guardrails. Now, this is a natural progression of expanding out the number of AI assets that are fully available, starting with models right now, which is going live soon, then moving into MCP as part of 3.0, and then being able to start working on other things like agents and guardrails, as well as prompts and knowledge sources, a couple other areas that we are looking at. By creating this centralized way of managing all of these pieces, you'll be able to leverage those MCP servers as well as the other assets together to form complex solutions. Now, enterprise-grade governance is absolutely crucial here. As I mentioned before, platform engineers need to feel comfortable with what they're putting out there and know that they are covering, all of the bases here to make sure that they are making sure they have a safe, secure environment, but one that runs very well, that they don't have to worry about it going down or just not being accessible from the people who need it most, these AI engineers. Now, the OpenShift asset plugin for DevHub is something also we're looking for, to be able to show these users in DevHub what they have access to from an MCP level, to be able to say, okay, I'm in DevHub, I don't want to go to multiple systems, so I can stay in DevHub, see those things. We're also looking at creating an MCP server for AI coders, which would be available in dev spaces, as well as developing locally. So this way you can see, your AI coders can see what you, the user, has access to and code against that immediately, as well as listing those things. So that way you can see it from a local perspective as well. This gives multiple layers of access to you in terms of MCP coming. Something else that isn't shown on here that I just want to make sure to bring up as well is that all of the Red Hat products are also working on their own MCP servers. Those MCP servers will be made available to everyone within the next year to be able to be consumed as well, to create these complex different agentic applications that allow for access to Kubernetes through OpenShift, access to Ansible and RHEL, as well as Lightspeed. So these different MCP servers will create extreme value for your different agentic workflows, to be able to pull these together and create magical new experiences. Adding those to Slack, adding Jira, adding to GitHub, and all of these different areas, working together in tandem with a bunch of other MCP servers. One agent able to access many different systems, or even agents speaking to each other using these different MCP servers to be able to make complex workflows take place. So with that, we do believe that over the next year, we will have a very strong end-to-end experience for MCP, as well as many other AI assets as we move forward. So today, thank you very much, everybody, for joining us. It has been wonderful to be with all of you, and we hope that this has been a guiding experience around AI and MCP overall. We look forward to any questions and feedback, and we will be available for such. Feel free to reach out if you don't get a chance to ask those questions right now as well. Thank you for your time today. Cedric, anything from you?
I just want to say thanks again, and great presentation, and hope you guys enjoy and have a great day.